Look at a rusty iron gate. Now look at a shiny copper wire. Then think about the bright colors in gemstones and solutions. All of them involve transition metals. Let's go a little deeper. Transition metals are found in the middle of the periodic table, and they behave very differently from most other elements. They're strong, dense, and excellent conductors, which is why they're used in construction, wiring, and machinery. But wait, here's the twist. Transition metals are famous for their colored compounds. Dissolve copper salts in water, and you get blue. Nickel compounds turn green. Iron can appear yellow, brown, or even purple. These colors come from the way electrons move within the metal ions, absorbing and releasing specific wavelengths of light. Here's something even more interesting. Transition metals are also powerful catalysts. They speed up chemical reactions without being used up themselves. Iron is used in making ammonia. Platinum speeds up reactions in car exhaust systems. Their partially filled electron shells allow them to interact easily with other substances, making them perfect for catalysis. Let's connect this to real life. Cars rely on catalytic converters. Industries depend on metal catalysts. Biological systems use metals like iron and copper to carry oxygen and electrons. Before we wrap up, zoom out for a moment. Transition metals show how electron structure controls strength, color, and reactivity. They're not just useful, they're essential. And that leads to the next question. If chemistry shapes industry so powerfully, how do large-scale chemical processes turn raw materials into useful products? That's exactly where we go next.